Hello everyone, today we're gonna learn section 4.3, partial derivatives. Okay, so we know what is a derivative means. So from calculus 1, we had derivatives, which is a slope of a tangent line, right? Slope of tangent line. So we had the graph. Let me draw the graph. X, Y, so like a curve, then that is a slope. So we denote f prime of a, right? So slope of a tangent line. Okay, so if we are using the formula with using the limit, right? So we have f prime of x, then limit h approach to 0, we have f of x plus h minus f of x over a. And this is a general formula. But if we want to find at a, then we can just change it, right? So we can say that if, hold on one second. So we can just, I can just write quickly, or f prime of a equal to limit h approach to 0, f of a plus h minus f of a over h, right? Okay, and then we have this notation, right? So dy over dx, which is the same as y prime, right? So we had this notation as Leibniz notation. It's hard to pronounce. Okay, now in calculus 3, we had the title for this section, partial derivative, right? Okay, what this means? How many slope of tangent line if we want to find the slope at the point? Yeah, let's talk about here. So I just picked a random graph here. So I want to know about the slope at this point. Yeah. So how many tangent line there? Can I draw here as a tangent line, right? Can I draw here as, can I draw here? Yeah. Can I draw there as tangent line at the point? So how about here, right? Ooh, that's not the one. How about here? Yeah. Okay. So look, I made a note here. So there are infinitely many tangent lines in 3-dimension space, right? So I can draw more. Yeah, infinitely many tangent line I can draw there, right? So what we do in this section, we do only x direction. X direction means x direction here, right? Because we have, this is x-axis, so that will be x direction, yeah? And then y direction, that means we have y-axis here, right? We can see that. So that will be y direction, right? So once again, there are infinitely many tangent lines in 3-dimension space. So we do only x direction and y direction of a slope of a tangent line. That will be partial derivatives. Make sense? Okay. Now we have the formula here. So calculus 3, partial derivative of f with respect to x means that we want to know about the slope of a tangent line with x direction, right? I'm not going to write down. I already explained earlier, right? Okay, then we have f prime of x, right? Okay, so we have this symbol. This symbol means partial. So this symbol from, we have Leibniz notation, right? So we had dy over dx, right? So we're looking at this one. We're looking at the y equation. That means we do derivative with respect to x, right? Okay. So this means we're looking at the f and then partial derivative with respect to x as it is, right? So partial derivative of f with respect to x. Okay. Then we follow same concept as calculus 1. But then we have two variable there, x and y, right? So f of x plus h and y minus f of xy. That's a function notation, right? In 3 dimensions with two variables, x and y, right? Or over h here, right? Okay. Now, we say that we have a partial derivative respect to x, respect to y, right? So we do only two, x direction and y direction, that's it, right? Okay, so how do we find the formula, right? So we are using f prime of y and then partial derivative of f respect y. And then look, can you see the difference? This is respect to x, this is respect to y. There is a difference between f prime of x and f prime of y in calculus 3. Can you see that? Okay. Now, let's do example here then. So we want to calculate partial derivative of f respect to x, partial derivative of f respect to y. All right? Okay, so we have the function. All right, so respect to x first. So let me bring this one. Okay. Okay. So, oh, straight. Okay, this is straight, right? All right. So this means we need to substitute, right? So in calculus 1, we don't have this one, right? Then what this means, we substitute this one into the function, right? Same as here. So if we see x, we substitute x plus h into the x. This is for y, right? But y, we just rewrite whatever they have. Make sense? Okay, let's do it. So substitute there, substitute there, substitute there. Yeah, and the y is just y. Okay, so limit h approach to 0, x plus h quantity squared minus 3, x plus h, and y there, right? And plus 2y squared minus 4, x plus h plus 5y minus 12. Yeah. Ooh, no space, huh? Huh. Okay, so sorry. Okay, we finished the first. Now we want to do second term. So minus f of xy, we can just rewrite, right? So let me just copy. Copy, paste, and then parentheses. And then pour over h, right? Sorry about that. Little bit doesn't look good, right? Okay. All right. Then let's keep continue. Limit h approach to 0. Okay. Then let's simplify everything. So first term x squared plus 2xh plus h squared minus. Okay, let's do this one. We have xh, hy, and then we make it times 3, right? So that will be 3 xy and minus 3 hy. Yeah. Okay. Plus 2y squared. Once again, we do distribute with negative. Be careful. So negative 4x, negative 4y plus 5y minus 12. Yeah. And then, oh, okay. So I'm not gonna make a bracket here so that we can simplify. And then we do this, distribute to all the signs. So there will be negative x. Oh, let me write down in the bottom so that we can simplify everything. X squared plus 3xy minus 2y squared positive 4x minus 5y plus 12 over h. Yeah, you guys follow me? Okay, let's simplify. We have nice. Yeah. Okay, so that will be limit h approach h approach to 0. So we have a 2xh plus h squared minus 3hy minus 4h, yeah, or over h. Okay, so we had experienced this kind of example, right? So factor out with h, 2x plus h minus 3y minus 4 or over h. Yeah. Then we get limit h approach to 0, 2x plus h minus 3y minus 4. Okay, we don't have any fraction. There is no quotient. So we can apply the limit when h approaches to 0, right? So that will be 2x plus 0 minus 3y minus 4, which is 2x minus 3y minus 4, right? Okay, this is general derivative respect partial derivative, right? So this is a partial derivative of f respect to x, right? Now, for this equation, for this function, Let's do derivative with respect y. So we have this one. Copy. All right. So let's see. We have the function. This time, with the substitute y plus h. When we see the y, right? And then x just x. Yep. Okay, let's do it. Limit h approach to 0, x squared minus 3x y plus h plus 2 y plus h quantity squared minus 4x plus 5y plus h minus 12 minus f of x, y. So just copy. I have this one, right? Forget it. It could complicate. With the negative. Or over h, right? Okay, so let's do it. So limit h approach to 0, x squared minus, let's take a look, 3x, we do distribute y, and then h, but it's negative, right? So let's do that. So we have 3xy minus 3xh plus, okay, so y squared, but we have a 2. Yeah, let's do that. So 2y squared plus 2 times a times b, which is 2yh, but it's 4yh, then h squared plus 2h squared there, right? Okay, now negative 4x plus distribute 5y plus 5h minus 12. Okay, minus distribute. So let me write down same vertical line. So negative x squared plus 3xy minus 2y squared positive 4x negative 5y plus 12 over h equal to limit h approach to 0. So we have h squared. Okay. So we get negative 3xh and plus 4yh. Okay, so since we have experience, let's factor out with h as well, right? So this is like calculus 1 technique, right? So we have h out. So negative 3x plus 4y plus 2h. And don't forget, we have a 5h in the middle. So plus 5 over h, right? So that would be, okay, now we have that. All right, so we don't have quotient anymore, so we can apply it when h approaches 0. So that will be negative 3x plus 4y plus 0 plus 5, which is negative 3x plus 4y plus 5. Yeah. Okay. Now, we found one. Okay. But then, like a calculus one, we don't using the limit, right? Because there's much way method we can apply. So we have all the formula, how to derivative, right? So calculus 3 as well, we have a partial derivative. We have a formula for the limit, but we don't use that because too much work. How many steps there, right? Okay. Now, how do you do partial derivative easily? Okay, let's take a look. So basically, when you make a partial derivative with respect to x, then x is the function, right? Then other variables, we treat them as a constant. Okay, if we have partial derivative with respect to y, then we treat, this is y as the function. So we do derivative, right? And then other variables, we treat them as a constant. Make sense? Okay, let's do same question using derivative as a partial derivative. Yeah, using the note, like a note. Hold on 1 second. I'm doing this one. Copy. All right. So we have same question. We want to partial derivative, so we denote the notation over the x. Yeah. Okay. Then think. So we have only x and y variables there. So think x is the function. Function variable and treat. How about treat? Treat. Treat. And y is a constant. All right. Okay. So we want to derivative x squared. What do you get? 2x. Very good. 2x. We want to derivative negative 3xy. Well, y is constant. We have a negative 3, so we are constant. So we keep that, right? So negative 3. Then y is also constant. Think about this is 100, right? Then negative 3 times 100. What's the derivative of x? It's 1, right? And we keep the only the constant. Make sense? Okay, so there will be negative 3y. Yeah. Okay. Y is constant. Y is constant. Yeah. Okay. Now we have a plus 2y squared. Y is constant. We want to derivative. So think 100 prime. What do you get? Y is constant, right? 0, right? So we have 0. Okay. Now, negative 4x. Derivative, negative 4. Yeah. And then we have a positive 5y. Y is constant. Same. 0. This is a real constant. 0. Good. Yeah. So that will be 2x minus 3y minus 4. Do we get the same answer? Check it out. Let's check. Yeah, we get the same answer. Yeah, 2x minus 3y minus 4. Okay, so we don't want to do that, right? Respect to y, because we found it's the same answer. Okay, let's do another example then. How about this? Second one, g of x, y equal to sine x squared y minus 2x plus 4. Okay, let's do maybe you can try the partial derivative with respect to y. Yeah. Okay, so partial derivative with respect to x first. All right, then same thing. Treat x is a function variable and y is the constant. Copy. All right. So we want to derivative sine. What do you get? It's a cosine. Good. We need to write down, yeah, whatever inside, and chain rule, right? So we denote notation like this. Normally we are using d over dx, yeah, but we want to make a partial derivative. So this d, all the time we are using like a partial notation, right? This d, right? So there will be d over dx, partial derivative with respect to x. So whatever inside chain rule, right? To respect x. Okay. There will be this one. Hey, come on. Okay. And okay, so let's talk about that. We have x squared, but we have a constant, right? So think about that. Think um 100 times x squared, right? Derivative. What do you get? So we keep the constant coefficient 100 times 2x. Yeah. Okay. So there will be y times 2x then, right? Make sense? Okay, negative derivative negative 2x, which is negative 2. Last term, real constant, which is 0, right? Okay, then that we have 2xy minus 2 then, right? Okay, normally we writing out this one in front, right? Because I don't want to multiply. Yeah, that's why. Okay, so there will be 2xy minus 2 cosine x squared y minus 2x plus 4. Okay, now let's do derivative with respect y then. Yeah, so okay, so let me copy. Think this time, think y treat y is the function variable and treat x is the constant, right? Okay, so let's take a look. We need to write down this one, right? Same as, right? So derivative of a sine, which is cosine, and then we want to make a chain rule, right? Oh, we should have copy everything. Copy everything. Mm, copy. Okay. So respect to y, change that, right? Okay. Now there will be that. So we are using chain rule. What do we have? This time is think differently. X squared is the constant. That means we keep that. And then what's the derivative of y? It's 1, right? So x squared, let me write down for you. Yeah, 1 is just unnecessary writing, right? Okay, minus derivative of negative 2x. It's a constant, so it's 0, right? This is a real constant, it's 0. So we have a 0, 0. Okay, then we had experience earlier, so I want to write down this one in front because I don't want to multiply it this way, right? So there will be x squared cosine x squared y minus 2x plus 4. Yeah. Is it good? Okay, so I brought a picture from the textbook here. So this is what I explained to you earlier about the slope of a tangent line with the partial derivative, right? Okay, but they indicate that the secant line, right? How will we get the secant line from the 2 points? So basically, this is from the algebra course, right? So in the algebra, we had that also slope. We indicate m, change in y, change in x, right? That is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Then in pre-calculus, we're using function notation, right? So that is f of b minus f of a over b minus a, right? Okay, now the secant line, right? So we have 2 points, we connect. Yeah, that is the secant line, right? So how do you find the slope of a secant line? So we're using just what we learned from the algebra course and the function notation we are using for the slope, right? Okay, now the 2 points getting close, each other, right? So very tiny gap there, right? That is a slope of a tangent line, right? So this is how we learn from the algebra 1. So then now in calculus 3, we are using this notation, right? So x plus h and y and minus f of xy over h. Okay, now partial derivative we talked and we practiced earlier, right? So once again, infinitely many slope of a tangent line. So we make a partial derivative means we make only the x direction, and we have a partial derivative of f respect to y means make only y direction, right? Okay, let's talk about that. Make x direction means parallel with x-axis. Yeah, x direction. This is x direction. Yeah, this is x direction. How about looking at here? X direction, right? So parallel to the x-axis. This is parallel to the x-axis, right? Okay. Then we say that this is xz plane. Yeah, xz plane. Then y equal to constant. So we can say that this is y equal to 0. Yeah, plane. This is a plane. Y equal to 0. And if we have this xz plane, then we call this is a y equal to probably 3. Here, y equal to 10, negative 10, right? That's why we say that treat y as constant. Make sense? Is it clear to you? Okay, now we say the partial derivative of f respect to y, right? That means y direction is here. This is y direction. Can you see that? Okay. This is y direction. Then that means parallel to the y-axis. How you make a parallel to the y-axis? This is parallel to the y-axis. Yeah. Make sense? Okay. If we make a parallel to the y-axis, that means z plane, yz plane. So this is a plane, right? Okay, then we can express this plane x equal to negative 8. How about that? Yeah. How about here? I want to make this plane. Then we can express x equal to positive 5, right? Make sense? All right. Then we understand why we treat x as a constant, right? Because this plane, we can express x equal to some constant. Is it clear to you? Okay. Now, let us do higher derivative, higher order partial derivative. Okay, let me bring up here. Okay, so we have a higher order partial derivative. So let's take a look this one. So instead of D, right? So we have this symbol, partial, right? Then everything is the same as calculus 1, right? Look, partial derivative function of f with respect to x. This is the first derivative with respect to x, right? And then we have another one. So with the derivative with respect to x, second. So when we denote like a function notation, so we denote like that. F sub xx, right? That means with the partial derivative with respect to x, then with the partial derivative with respect to x, second one, okay? Now, same, so we have y first, then x. Then this one, we have a partial derivative with respect to x, partial derivative with respect to y. So we have the same thing there. There is, right? And we have a partial derivative with respect to y, then partial derivative with respect to y, second. Okay? Okay, let's do example. Okay, so we have a function here. Calculate all for second partial derivative for that function. So 4, so we should know that, right? So we need to find the partial derivative with respect to x, then x, partial derivative with respect to x, then y, partial derivative with respect to y, y, partial derivative with respect to y, then x. Yeah? Okay. So let's do that. In order to do that, we have to have partial derivative with respect to x first. Okay. So treat y constant, right? We understand why, right? Okay, so the first one, this is a constant, right? Then derivative of this, it's 1 times the constant, right? So coefficient, so 1 times that. Okay, we want the derivative. What again? This is cosine, right? So plus cosine 2x minus 5y. And then chain rule. Partial derivative with respect to x. Okay, so that will be e to the negative 3y plus cosine 2x minus 5y. And y is constant, so this is 0. And derivative of 2x, which is 2, right? So let's write down 2 here, then we can save the time. Yeah. 2 is here. Make sense? Okay. Let's have derivative with respect y, right? So derivative with respect, partial derivative with respect to y. Okay, so let's take a look at this one. Then we do treat, think x as constant, right? Okay, now this is a constant, so we keep that x. Then e to the negative 3y chain rule, right? And plus derivative of sine cosine 2x minus 5y and partial derivative with respect to y. Okay, then chain rule. So we have x e to the negative 3y. We do partial derivative with respect to y. So this is y. So we get negative 3. Let's write down in front. Okay. Then plus we have a cosine 2x minus 5y. Partial derivative with respect to y. Then first term is 0. Second term is negative 5, right? So negative 5. Make sense? Okay. Now, let's find second partial derivative with respect to x. Okay. So we have this. Copy. Ooh, okay. So partial derivative with respect to x. Okay, now partial derivative with respect to x. Okay, so looking at the partial derivative with respect to x, this one, and then we want to partial derivative with respect to x again, right? Okay, then this one is 0. And we have a 2 cosine, so derivative of a 2 cosine, which is negative 2 sine of 2x minus 5y. Partial derivative with respect to x of chain rule. Okay, that will be negative sine 2x minus 5y. Okay, derivative with respect to x. So just the 2. Just 2. You may write down 0. Well, you are okay, right? So let me write down 2 minus 0. How about that? Yeah. Okay. So there will be 2 then negative 2. Hold on 1 second. I'm missing 2 there, right? So 2, I'm missing 2 there. So sorry about that. 2, 2. So we have negative 4 sine 2x minus 5y, right? Okay. So this is the first, this second. All right. How about we have the first, then second, first, second. So this time we're looking at the y. So derivative with respect to y. So e to the same, e function same. So e to the negative 3y and the chain rule, right? Respect to y plus derivative cosine 2 cosine, which is negative sine 2, and then chain rule respect to y, right? Okay, so we have e to the negative 3y, derivative with respect to y, negative 3, and minus 2 sine 2x minus 5y. And derivative with respect to y, 0 minus 5. So that would be negative 3 e to the negative 3y. Minus minus is positive 10. Positive 10 sine 2x minus 5y, right? Okay, so 2 more left. We have y, partial derivative with respect to y. Copy. Partial derivative with respect to y. Okay, so we want to know about this one first. Okay, so this first we did that. Second. Okay, so partial derivative with respect to y. So y, ooh, we have a 2, right? Okay, that means we treat x as a constant. This is a constant, so we keep the constant. But we want the derivative about the y, right? Keep the constant, e to the negative 3y, and chain rule, right? Make sense? So negative 3x, e to the negative 3y, chain rule, respect to y, plus, and then derivative of negative 5 cosine, it's a negative sign, so it's a positive sign then, right? Positive 5 sine of 2x minus 5y, and chain rule, respect to y, right? Chain rule. Okay, now, what's the derivative respect to y? It's negative 3, right? So we have negative 3x. Let me just write down everything because I think we need one more step. 5 sine 2x minus 5y. Derivative with respect to y. So negative 5. So 0 minus negative 5, right? 0 minus negative 5? No, 0 minus 5. So we have a negative 3 times negative 3, positive 9, x e to the negative 3y. Good job. And then negative 25 sine 2x minus 5y, right? Okay, last one. First, second, right? Partial derivative. Okay, so we are looking at this one. Partial derivative with respect to x then, yeah? So this is a constant, y is a constant, we keep the constant, right? Then what's the derivative of negative 3x? Just negative 3, right? So we have negative 3, and then e to the negative 3y, derivative of negative 5 cosine, so positive 5 sine of this. Let me copy them, yeah? Positive, copy, paste. And then this is respect to x. Okay, so that will be negative 3 e to the negative 3y plus 5 sine 2x minus 5y. Derivative with respect to x, just positive 2, right? So positive 2 minus 0. So that will be negative 3 to the negative 3y plus 10 sine 2x minus 5y. Yeah, okay. Let's take a look. We have partial derivative with respect to y, then x. We get that. Yeah. Let's see. How about here? Partial derivative with respect to x first, then y second. We get the same thing. Can you see that? Let me make it smaller. This and this. Oh, this and this, same. Okay, we conclude. We say that, note. Partial derivative respect x, then y, same as a partial derivative respect to y, then x. Yeah. Okay. Now, how about 3 partial derivatives? Let's do this one. Let me bring the example. Okay, so this is the question. So is this function partial derivative of x first, then y second, z third is the same as y first, x second, z third, right? So let's do it. So let's do partial derivative with respect to x first, then treat y, z as a constant, right? Okay, so derivative of sine, cosine, x squared y minus z, and chain rule, so derivative was inside respect to x squared y minus z, and what's the derivative of cosine? Negative sine x squared minus yz, and then chain rule, whatever inside the derivative with derivative with respect to x, which is x squared minus yz. Yeah. Okay. Now we have a cosine x squared y minus z. What's the derivative with respect to x? So we have x squared there. So 2x, y is constant. So we keep that. So 2xy, right? And then the z is 0. So 2xy minus 0 minus a sine x squared minus a 4, not 4, it's y. Yeah, yz. What's the derivative with respect to x? 2x, then 0, right? So 2x negative 0. Yeah. Okay, so we have a 2xy cosine x squared y minus z minus sine x squared, oh, 2x there, right? So we have a 2x sine x squared minus yz. Is it okay? All right, so let's do that. Second one, derivative with respect to y. So z of with the partial derivative with respect to y. So treat xz as constant, right? All right, so looking at this one, so we are using product rule, y, right? So f g, so we do derivative, f prime g plus f g prime, right? Okay, so we will get respect to y. So this is a constant, so 2x, f prime, which is 2x, g, and then f, g prime, negative, right? Negative sine x squared y minus z and chain rule respect to y, right? And the second term, we do respect to x, right? But then there is no x. So this is a constant. Yeah, makes sense? So we don't need to have the product rule, right? This is a constant. So look, think about this. We have 100 sine. Let's say that x. How about that, right? Derivative. We keep that coefficient. Then what's the derivative of sine? Cosine, right? X. Yeah. Okay. So we don't need the product rule. So this is just a constant, second term. So that will be negative 2x and derivative sine, which is cosine x squared minus yz and chain rule respect to y x squared minus yz. Yeah. One. Okay. Uh, first term. Second term. So minus 2xy sine x squared y minus z. What's the derivative with respect to y? We have a 2x minus 0, right? Minus 2x cosine x squared minus yz. What's the derivative with respect to y? That is 0 minus z. Yeah? Because z is constant. Yeah? Okay, let me rewrite. Whew. So we have a 2x cosine x squared y minus z. And then 2x times 2x minus a 4x squared y sine x squared y minus z minus 2xz, negative, negative, positive, 2xz cosine x squared minus y. Yeah, okay. Too much work. So let me do this. And then please try this one. And let me know whether they are same or not. Okay? All right. Maybe when you watch this video, make a comment in the YouTube video, right? Yeah. All right. So let's do the third one. Z. Let's take a look. Oh no. I made a mistake. Sorry about that. This will be xy, right? So I was using the derivative with respect to x. Yeah. And then second derivative with respect to y, right? Now z. So I cannot say well. X, Y, Z. Yeah. So we're looking at this one. All right. So last one. Think. Uh, Z. So treat X, Y as a constant. All right. Uh, Z. We don't have a Z. So this is a constant. We keep that. 2x. Cosine derivative of cosine sine x negative square y minus z. Ooh, luckily there's no z, so it's a constant. Oh, chain rule. Sorry about that. I'm so tired right now. So derivative with respect to z. So we have x squared y minus z. Okay, second term. No z, so it's a constant. So we keep that. What's the derivative of sine, cosine of that? Chain rule. Yeah. Okay. Very good. Minus 4x squared y cosine x squared y minus z. And derivative with respect to z, x squared y minus z again. All right. Third term, we have to use product rule because we see the z there, right? So this is f, this is z. So f prime g plus f g prime, right? So there will be, sorry, f prime 2x, yeah. G f G prime. And then chain rule, respect to Z. Okay, so there will be first term, negative 2x sine x squared y minus z, and derivative with respect to z, 0 for the first term, negative 1, right? 0 minus 1. Second term, negative 4x squared y cosine x squared y minus z. And what's the derivative with respect to z? Oh, same. Yeah, 0 minus 1. And third term plus 2x cosine x squared minus yz. Last term, negative 2xz sine x squared minus 4z. What's the derivative with respect to z? 0 minus y, right? Okay, let's arrange negative. So positive 2x sine x squared y minus z. And second term, second term is a positive 4x squared y cosine x squared y minus z. And third term plus 2x cosine x squared minus yz. Last term minus a positive 2xyz sine x squared minus 4z. Yeah. Okay. So once again, this is derivative with respect to x, then y, then z. Can you please find out? This one? You try. You trying this. Yeah. And then please write down in the comment. Yeah. Thank you very much. Thank you very much for watching, and I will see you in the next section. Thank you so much. Bye.